Yes, once again, welcome my friends for the session number 2 for frequency domain analysis of module 4 in control engineering, that is for 7th semester mechanical. Let us understand the concept of polar plot by drawing some of the polar plots with some examples. So here example number 1, sketch the polar plot for the following transfer function, that is g of s into h of s, k divided by 1 plus st. So here we start with the solution. The given data is, that is the transfer function, that is open loop transfer function, that is g of s into h of s. If it is given closed loop transfer function, you have to convert into open loop transfer function. Yes, what is the definition of closed loop transfer function? That is the ratio of output to the input variable, that is g of s into h of s, that is given by g of s divided by 1 plus g of s into h of s, that is closed loop transfer function. So if it is given closed loop transfer function, your job is to convert to open loop transfer function, that is g of s into h of s. So here in this example, that is directly given g of s into h of s, that is open loop transfer function, that is equal to k divided by 1 plus st. So here identify the system type number and order number. So here system type number is 0. Why it is 0? The independent s term in the denominator, that is not there. So here k divided by 1 plus st. If it is k divided by s into 1 plus st, that is s into s plus 1 plus st, that is the power of s in the denominator, independent s term. Here there is no power, here there is no s term in the the denominator. So here the type number is 0, that is s to power of 0 is nothing but 1 itself. Okay, and the order number, that is the power of s term in the denominator. So that will tell the power, that is highest power of s term in the denominator is s to the power of 1, that will give the order, nothing but the polynomial of s in the denominator. So that is highest power is 1. If it is s into 1 plus st in the denominator, so combine both s into s, that is s square. So now the order will be 2, that is the highest power of polynomial of s in the denominator. But in this example, that is 1 plus st, so s to the power only 1, hence order is 1. So you may ask, why this type number, order number required? So this will tell directly if you are solving some many examples. By seeing the type number and order number, you can predict or you can judge the polar plot, where exactly it is crossing, from starting point, which is the starting point, which is the ending point of polar plot, something like that. Okay, so here once again, yes, different steps are there. First step is note down the given transfer function carefully, and second step is replace the s by j omega. Before that, after note down, you have to adjust the s to 1 plus st form. It is directly given here, k divided by 1 plus st form. So here no need to adjust. So next, replace s by j omega in the above transfer function and adjust the term to 1 plus st form. Okay, so replace s by j omega, that is g of s into h of s, nothing but g of j omega, h of j omega, that is equal to k divided by 1 plus st is there. So k term, that is a constant term, you can write into 1 plus st, or real part some imaginary parts. So k plus 0 j omega, 0 into j omega, that is 0, so only remains k in the numerator. So whole divided by 1 plus st, that is 1 plus, instead of s you have to replace, right, j omega, 1 plus j omega into t. So here that is the the second step. Third step, once again find the magnitude ratio and the phase angle or phase shift. So here the equation for magnitude ratio is given here, that is m omega, that is real parts of numerator square, imaginary part of numerator square to the power 1 by 2. or you can call that also square root of s real square of numerator, square root of real square of numerator plus imaginary square of numerator, that is whole divided by once again real square of denominator plus imaginary square of denominator to the power 1 by 2, or you can call square root of real square of denominator plus imaginary square of denominator. So once again see the s g of j omega h of j omega, that is k into k plus 0 j omega whole divided by 1 plus j omega t. So there find out the s value of m omega, that is equal to, what is real power of numerator, that is k, that is k square. What is imaginary part, that is 0, coefficient of j omega, that is imaginary part, so it is 0, so 0 square, k square plus 0 square to the power 1 by 2 whole divided by s real square of denominator, that is the first 1 square plus s omega square t square, so coefficient of s the imaginary, that is j, so omega t, that is omega square t square to the power 1 by 2, or you can also call as square root of 1 square plus omega square t square. So finally simplify further, so m omega equal to k into k whole divided by 1 plus s omega square t square to the power 1 by 2. So for this you can call equation number 1, that is the equation for magnitude ratio m omega. Next, coming to the phase angle or phase shift, which is given by phi omega equals to tan inverse of imaginary by real part of numerator of that transfer function minus tan inverse of imaginary by real part of denominator of that particular transfer function, that is converted to s to j omega. So once again further you write phi omega equal to s tan inverse of 0 by k, that is a numerator term, minus tan inverse of omega t by 1, that is denominator part. So finally further simplify, tan inverse of 0 is nothing but 0, so directly phi omega equal to minus tan inverse of omega t, that you can call equation number 2. Moving to the next slide. So what is the next step? Substitute the limiting value of s omega as 0 and infinity separately. So first you can substitute omega as 0. Let us see how the m omega and phi omega, what value we will get it. Okay, so first you substitute omega as 0 in magnitude ratio, that is m omega. So m omega equal to only k, because here that m omega is k divided by 1 plus omega square t square to the power 1 by 2, that is m omega. S omega is 0, that is denominator terms decrease to 1 plus 0, that is 1, square root of 1 is 1, so k by 1 nothing but k itself. Okay, once again omega equal to 0, that is phi omega equal to 0. How? Once again omega is 0, you see in the equation number 2, that is phi omega equal to minus tan inverse of omega equal to 0 into t, that is 0, that is phi omega is tan inverse of 0, that is 0. Next you substitute once again omega to infinity in both the equations, m omega as well as phi omega. So here m omega is k divided by, what is that, equation number 1 plus omega square t square to the power 1 by 2. So when omega equal to infinity, so k divided by 1 plus some infinity, that is k by infinity. What about the phi omega? If omega tends to infinity, that is minus tan inverse of infinity, that is minus tan inverse of infinity is equal to minus 90. So here after substituting the limiting values of omega to 0 and infinity, we are getting m omega is k value, phi omega is 0 value. When you substitute the omega as infinity, the m omega, that is magnitude ratio, is k by infinity, and phi omega is minus 90. Okay. So as I told, so after substituting the limiting value, in between you can substitute for the third point to get the smooth curve. So only for starting point, ending point you are getting. What about the third point? So there you have to substitute omega as 1 by t. So in such a way that you just see the equation, m omega equation and phi omega equation. So omega as 1 by t, so that 1 by t square cancels, 1 plus 1 square root of 2, that is k by root. So like that you have to cancel the the t term. So it's like that you have to substitute the value of omega in equation 1, equation 2. So here if substitute omega equal to 1 by t, the m omega, that is magnitude ratio, is in equation 1, that is k by 1 plus omega equal to 1 by t, 1 by t square, that into t square cancels, then 1 plus 1, that is 2, power 1 by 2 means root 2, that is k by root 2. We just see here k by root 2. Okay. And what about the phi omega? So phi omega we just see here, that is phi omega equal to minus 45. How? We just see here. So equation number 2, what is that? So that is phi omega equal to minus tan inverse of omega t. Instead of omega you substitute 1 by t. So that is 1 by t into t. So t cancels, so only 1. Tan inverse of 1 is, that is the 45, that is minus 45, because it is minus of tan inverse of omega t. So that will have the minus 45. So taking the suitable scale, locate the points using the polar coordinates and draw the smooth curve passing through all these 3 points. So first point is as omega is 0, second point is instead of, that is last point is omega is infinity. So in between 0 and infinity, that is omega is 1 by t. So there m omega is k by root 2 and phi omega is minus 45. So with this one you can draw the graph in a polar coordinate on S plane, as I told already. So here what is that? The angle always you have to see here in case of polar coordinate, that is along x-axis, that is 0 degree, and this one is minus 90, and this one is minus 180, and this one is minus 270. So like that you have to draw the angle in a clockwise direction. So always represent in a negative, 0, minus 90, minus 180, minus 270, like that. So initially when k is omega is 0, that is here, and omega is infinity. So omega equal to 0, what is the value of k? See here, omega is 0, m omega is k, phi omega is 0. M omega is magnitude ratio, that is radius, phi omega is, that is theta. So here the theta is 0 degree. What about the m omega? That is k, that is shown here, from here to here with a radius of k, this value. Okay, that is the first point. Similarly, when omega equals to infinity, that is m omega is 0. What about the phi omega? That is minus 90. That you see here. That is m omega equal to infinity, m omega is k by infinity. Nothing but a small term by big term, that is equal to 0. Here we have to actually show this k by infinity. Infinity is a very large term, so k by infinity is 0. So m omega is 0, nothing but radius is 0. So what angle? That is minus 90 degree. Phi omega is minus 90. That is, just see here. So at minus 90 degree, m omega is 0. This is the first point and this is the second point. So with this third point, when omega equal to 1 by t, omega equal to 1 by t, that is 45 degree line you have to show here. Theta is 45 degree. What is the radius? That is k by root 2. That is the third point here, center point of this one. Okay, this is k unit and this will be the k by 2, or maybe this side will be the k by 2. So third point, this is the first point, this is second point, and this is third point. So with this join the smooth curve like this from outwards to inward. Arrow, see the arrow mark here, outward to inward by center point is this one. This is the radius, that is r equal to k by 2, because this length is k, that is shown here, that is not scanned properly, but this distance, that is radius, is k, half of that is k by 2. This is the polar plot for the example 1. Is coming to the another example. Example number 2, sketch the polar plot for the following transfer function, that is g of s into h of s into t whole divided by 1 plus st, s into t divided by 1 plus st. So here the given data, down the transfer function carefully, that is g of s into h of s equal to st divided by 1 plus st, and identify the system type number, order number. So here type number, that is independent test term in denominator, nothing is there, then as usual s to the power of 0 means once again 0. There is no any independent test term. Order number once again, that is 1. The denominator, you just see the power of s term in the denominator, only one s term, that power is 1. So once again, next step is adjust into 1 plus st form, which is already there in the 1 plus st form, the denominator. Only for the numerator you have to adjust and replace s by j omega. So that you can see here, replace by j omega, g of j omega, h of j omega equal to, that is shown here, that is st in the numerator. How to write that one? 0 plus j st, 0 plus st. So instead of s, we have to replace j omega, 0 plus j omega t whole divided by 1 plus j omega t. So this is your s transfer function, which is replaced by s by j omega term. So here by this one you have to, step number once again, that is third, is find out the magnitude ratio and phase angle. So how to find magnitude ratio? That is given by m omega equal to the real square of numerator plus imaginary square of numerator to the power 1 by 2. That is whole divided by real square of denominator plus imaginary square of denominator to the power 1 by 2. So here m omega equal to, that is the real square of numerator, what is that one? 0 square. Similarly imaginary part, that is omega t, square means omega square t square, that you can see here, omega square t square to the power 1 by 2. So whole divided by, once again, s real square of denominator, that is 1 square, plus imaginary square is omega t, that is omega square t square, and to the power 1 by 2. So further simplification, once again, what is that? After further simplification, you just see 0 square nothing but 0 only, plus omega square t square to the power 1 by 2 means just only omega in t, whole divided by, that is 1 square nothing but 1, and omega square t square to the power 1 by 2. This is called equation number 1, that is m omega. Okay, similarly the phase angle, phi omega equal to tan inverse of imaginary by real of numerator minus tan inverse of imaginary by real of denominator. So here tan inverse of imaginary by real of numerator is, that is 0 and omega t. Okay, first imaginary part you have to take omega t divided by real part is 0. So anything by 0, that is infinity. Tan inverse of infinity, this term. In this term, tan inverse of imaginary by real of denominator, that is tan inverse of what is imaginary, omega t, real is 1, that is omega t. So finally tan inverse of infinity is 90 minus tan inverse of omega t as it is, we can call equation number 2. So these two are the, yes, equation number 1, that is magnitude ratio, equation number 2, that is phase angle. Further substitute the limiting values of both, what is that one? Omega is 0 and omega is infinity. So if you substitute the omega is 0, m omega is 0 and phi omega is 0. Okay, that is omega in the the equation number 1 and the equation number 2. So omega tends to infinity in equation number 1, m omega, that is there, that is equal to 1. Yes, omega t divided by omega square t square to the power 1 by 2, that is 1. Phi omega is 0. Okay, and once again in between 0 and infinity, substitute the omega as 1 by t, that is m omega is, yes, 1 by root 2, 1 by 2 to the power 1 by 2, and phi omega is 45 degree. By taking suitable scale, yes, draw the polar plot as omega tends to 0 and omega tends to infinity and omega tends to 1 by t. You can see here the polar plot. The first one is omega tends to 0, m omega is 1, and omega tends to infinity, yes, m omega is 0. This is 1 and 0, 2 points. So in between, once again, omega tends to 1 by t, that is m omega is, what is that one? In this direction, that is 1 by root 2 at 45 degree line. So form this one, that is in the first quadrant. is not minus 45, this is plus 45. So that you take along this one. So if you are taking downward, that is minus 45, because we are taking the clockwise direction, that is minus angle. Here 0, minus 90, minus 180 and minus 270 like that. But here that is plus 45, that is you have to go to the anti-clockwise direction, that is from real axis, positive real axis 45 degree from origin to this point, and this diameter is hypotenuse value is 1 by root 2. If this is 1, this is 1 by root 2 as Pythagoras theorem. You make a right angle triangle here, this is 1 by half, this is half, 1 by 2, 1 by 2, and this direction will be 1 by root 2. So hence we are taking 3 points, point number 1 and last, this is when omega tends to 0, what is m omega phi omega, omega tends to infinity, m omega phi omega, in between omega tends to 1 by t. So join the smooth curve. So last example we are getting the polar plot here below, but this time it is above. So like that, by taking all the values, you will draw a smooth curve and draw the root locus plot. So with this I conclude my session 2. Thank you.